Hi everyone, welcome to our video on finding the absolute extreme values when we have this log function involved. Alright, so finding the absolute extreme values, for our first step, we will find the derivative. So we want to do f prime of x equal to, alright, so this is just the power rule, the first part, which is 8x, and then minus 128's hanging out. The derivative of the natural log of x would be 1 over x. And notice it's on this interval, so we know absolute extrema will exist. All right, well, all I'm going to do in this next step is just simplify our second term there. So it's 8x minus 128 over x like that. Okay, so now that I have it simplified, this is looking good. Well, usually at this point, we want to get a single fraction. Okay, so now I've got, let me get my pen, it switched on me. Okay, so let me put it in blue. So now what I need is to get a single fraction with this portion right there. Okay, so this, let me mark it. So we need single fraction with this portion. Okay, and that 8x is really over 1. So that means all I have to do is multiply the bottom by x and multiply that top by x. Okay, so it doesn't look the best right now, but let's fix it. So f prime of x is equal to, now we have a single fraction. 8x times x would be 8x squared, and then minus 128 over the common denominator of x. Okay, so that's what we wanted. And then now that we have this, well, it looks like I could take an 8 out of the numerator. So let's continue to factor. Okay, so 8 is getting taken out, and I'd be left with x squared minus 16. So 8 times 16 is 128 over x. And then notice x squared minus 16 continues to factor. So we have f prime of x is 8. And then x minus 4, x plus 4, all over x. Okay, so this, I'm going to cloud, this is our factored derivative. It's completely factored. And then if it's a fraction that we have here, to find the critical numbers, we want to set all of these factors, set all factors, including the denominator factor, set all factors to 0. And I usually keep it on the left side. I kind of split these in half. Okay, so I need to set all of these factors equal to 0. Well, setting 8 equal to 0 doesn't really make sense. So that you can just cross out. But let's move on. X minus 4 gets set equal to 0. X plus 4 can get set equal to 0. And then the denominator, x, equals 0. Okay, and then now I want to solve all of these. Well, if we solve all of these, let me scroll a little bit. So they're all pretty easy to solve. Notice with our x minus 4, all I have to do is add 4 over. So I would get x is 4. With this one, I would subtract and get x is negative 4. And then x equals 0 is already solved for. All right, but what we need to do is make sure that those are in our interval. Oops, that's a little too far. Okay, so with our problem, our interval started at 1 and went to 5. Okay, so that means looking at these, negative 4 is not in the interval, so goodbye. 0 is not in the interval, so goodbye. So x equals 4 is the only critical number. Okay, and I boxed it. It's not a final answer, but that's often a little bit more important than some other things. Okay, so I have x equals 4 as our answer, and then with this, now I can find our extreme value. So our second step is to just plug all of these in. So into our original f. So we start with our endpoints. So let's go ahead and circle that. So our endpoints. So I want to do f of 1. I want to do f of 5. And I want to do f of 4. Now with the natural log, they might want us to keep the natural log involved. So for instance, when I do plug in 1, So I want to plug 1 into our function here. So that's 4 times 1 squared. So we've got 4 times 1 squared minus 128 natural log of 1. Well, 4 times 1 squared is 4. 128, natural log of 1 is 0. Just going to put that at the top. So that means this would be 0. So we have just 4 left over. So just 4 is that first one. All right, now let's see these other ones. So if I plug 5 in, I'd have 4 times 5 getting squared minus 128 natural log of 5. All right, well, 4 times 5 squared. 5 squared is 25 times 4 is 100. And then this portion, well, if they want you to keep it in terms of logs, we would keep it in terms of logs. So 128 natural log of 5. So let's cloud that too. Okay, so on this one, I'm assuming they want an exact value. If they wanted a decimal, we could just plug it in, and we will. We're going to check either way, but let's leave it like that. Okay, and then when we plug 4 in, I'd have 4 times 4 getting squared minus 128 natural log of 4. Okay, so let's see what happens here. Well, 4 times 4 squared is 64. So we have 64, and then again, if they wanted it in terms of natural log, it'd be 128 natural log of 4. Now let's cloud that up. Okay, so this is where we need our calculator because we don't know what these are going to be, but we need to estimate them so that we could actually see what our smallest and biggest values are. Okay, so let's go to our calculator. Okay, so this was from a previous problem, so let's go ahead and just delete all of it. Let me move it a little bit. Okay, so let's go ahead and I'm going to say delete all. And let's get the one that we have in. So 4x squared minus 128 natural log x. Okay, so that was our function. And then just like the last one, if you want the interval that's given, you just do brace. And we put the first value 1. Then we do less than or equal to x, and then less than or equal to 5, and then another brace. Okay, so that's that. Okay, so we can see our function here. Looks like it's just a line. That's a weird looking graph, huh? Okay, so it might be better to try to zoom in or zoom out. Looks like it's still just a line. Either way, that is our graph. Okay, so it's there it is. There it is. There's this full zoom out. Okay, so zooming in a lot. But we might not really need the picture anyway. It's nice to have, but kind of the main part of it. Let me kind of move it a little bit so you can see everything. So the main part of it now, I would say, is use the table. Okay, so I don't want that. Let's go say done. Yeah, I didn't want that. Table. Okay, so now that I've at the table, well, I can plug those values in. 1. Notice the -1, the 0 are undefined. So we had 1, we had 5, and we have 4. Okay, and then these other ones I don't really want, so let's delete. So they're not in the way. Okay, so there's our 3 values from the graph, or from our function. And so it looks like when you plug the 4 in, the 4 right there has a more negative value. It's lower in the graph. So that is right there. It is lower. That's the lowest y-coordinate then, the -113.446. Okay, so that's what it appears these are. So let me go ahead and write those decimals out next to them. Okay, so let me move that over. And we're going to write those out just kind of next to them here in this problem. Okay, so I got my pen now. Okay, so this one, the middle one, this one right there. Hello, pen. My pen's not working. Hold on. Okay, so let me try to fix that real quick. Okay, so I think it's sort of working. Okay, I don't know what's going on with the pen lately. Well, it seemed to be working. Okay, so there it is. Okay, so it just won't show the little dot on me. Okay, so now I'm wasting everyone's time. Where's my pen? This is annoying. Alright, seems to work every now and then. Okay, so hold on. Sorry, guys. Okay, let me just kind of arrow it. Okay, so I'm just going to use my mouse. Okay, so this one right here, that one was the negative 1.06. Come on, pen. Oh, this is looking really bad on me, huh? This pen. Hello, pen. I kind of need to write I need just 30 seconds. Okay, so just still working on this pen. I thought I had it fixed. I keep pausing it. Okay, so this pen is getting real bad. Sorry. We're so close. We might need to just end this verbally. There it goes. Okay, so that is the negative 106 to just a whole number. Negative 106. This one was the negative 113 to the nearest whole number. And so that lets us finalize it with our absolute extrema. So we could definitely see what the biggest one is. The biggest one is 4. Okay, so let's finish this off. So we've got the absolute max is 4 at x equals 1. And then we want to finish it off with our absolute minimum. Well, the absolute minimum, I'm going to write it in terms of that log. So that middle, the negative 113, this is the smallest value, but I'm just keeping it sure so it's in exact values. And again, that's why the calculus is important to get to this exact value instead of just a pure decimal. All right, so let's write that in. So we have our absolute minimum is 64 minus 128 natural log of 4 at x equals 4. Ooh, okay, Pin, come on. You got this. We got this all together, don't we? Boom. Okay, so there it all is. Okay, so our smallest y value was that weird natural log. But if it wanted a decimal, I mean, use the decimal. I just decided to use a log because I think maybe they would want an absolute value. Or an exact value. Sorry, not an absolute value. Okay, so sorry about the pen. Hope everything went well, though. And you've got the process down for extreme values. Okay, if you don't, let me know. Ask me questions. Otherwise, thanks for watching, and I'll see you next time.